Hello everyone, my name is Prime. Welcome back to another video. In this video, we're going to be talking about logic gates. Now, there are three main logic gates we need to know: the OR, the AND, and the NOT gate. Now, these three gates basically can make up the rest of digital logic, and using these in sequence will allow you to create very sophisticated circuits. Alright, so let's go over these individually. Let's start off with OR. OR has a symbol that looks like this. I can't draw very well, but here's our output. And here are two inputs, A, B. So different circuits have different truth tables. Now you might be asking, what is a truth table, Efraim? Well, a truth table is basically a table A, B, output. A truth table basically dictates the states of each wire. So let's take an example. An OR gate has a truth table that looks like this. When A is 0 and B is 0, that means both these bits are 0, our output is a 0. 0, 1, where A is 0 and B is 1, our output is going to be 1. And vice versa for A and B if we switch those. Now an OR gate also has a fourth state because this is a 2-bit input. That means 2 to the power of 2 means 4 possible results. Alright. In the OR gate though, when both are on, the output is also on. So what we end up with is a truth table that looks like this for an OR gate. Alright. Now that we know what an OR gate is, we're going to move on to what an AND gate is. Alright, an AND gate, let's write AND. An AND gate looks like this. I'll have to excuse my horrible drawing skills. You have A, B, and the output. So, a truth table for an AND gate is a little bit different than an OR gate. Let's draw the table. Alright. So in this case, if both are 0, our output is also going to be 0, similar to an OR gate. Now this is where it becomes different. When A is 0 and B is 1, the output is also 0. And the same thing goes for when A is 1 and B is 0. The output is 0. But here's the fun part. When both are on, the output is on. So we have an AND gate, basically. An AND gate, basically, I said basically twice. An AND gate, when both are on, the output is on. In any other case, the output will be off, as you can see here. So there's only one case where an AND gate is on. Now let's move on to the NOT gate. A NOT gate is a little different than the other gates that we've covered so far. It looks like a triangle with a little dot on the top. So A, and then we have our output. Alright, so let's take A and then output and draw a little truth table for this. Now since this is 1 bit, that means there are only 2 possible inputs. 2 possible. So we have a 0 and a 1. Now the output of a NOT gate is basically the inverse of what this is. So this is 0 and a 1. Now this basically, this kind of truth table use will allow us to create much more sophisticated circuits later on. Now more advanced circuitry uses different kind of logic equations or tables. So let's take, for example, output. let's make a truth table first. So A, B, let's make this an AND gate. We're gonna just call this O from now on. 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1. Alright, so this basically means that this will only be on when A is 1 and B is 1. Let's take an OR gate. This is AND OR. Alright, so let's take an OR gate. Output will equal when A or B is on. Alright, so 1 plus 0, always going to be 1. 1 plus 0 on, 0 plus 1 on, 1 plus 1 on. Alright, let's take an XOR. Now an XOR has two ways. It has A, B inverted, so bar on top. So this basically means when A is 1 and B is 0, that's what the bar means. And, or basically, the other case is when A is 0 and B is 1. This is my understanding of it. You might want to correct me. So this is my way of thinking of it. Output can, for an XOR, can only be on when the two are different, in no other cases. So let's take a larger circuit. Let's take the 3 inputs, A, B, C. And the equation for output is going to be AB plus plus C bar A plus B bar. Alright, so since they're all pluses, at the end we're going to have an OR gate. Now this OR gate, since there are 3 different cases, it's going to have 3 inputs. So basically it's the same as a 2-input one, but they're just sequenced together. Here, so for a 3-input OR gate, it's going to look like this. That's an OR gate. And then you have another OR gate here. So now you have 3 inputs in one. Alright, so let's look at the first case. When A and B are true. So that means we're going to have an AND gate for AND, because they're multiplied. And that's just going to connect to here. Okay, C bar A. So that means now to invert this, feed this into an AND gate, and connect this to the OR gate. And we're going to have to connect the A to here. And the last case is when B is inverted. We're going to bring that in. So this whole expression is this equation right here. Excuse my phone. So this equation right here is our circuit right here, output. So let's go over what we covered today. We covered the different gates, so we covered AND, OR, and NOT. We also covered expressions and truth tables. In the next episode, we're going to be talking about encoders and decoders and what they mean for digital circuitry and all of that. I forgot to mention this last episode, but I'm using Epic Pen for the marks. So as you can see here, I can lightly bring it and then press hard like a real pencil. So yeah, I hope you enjoy it, and I'll see you in the next episode. Bye bye.